Hi, good afternoon, everyone. We'll start sharp after 2 minutes. Yeah, see you then. Hello, everyone. Good evening. So before I start, if somebody can just let me know I'm audible and clear.
You're audible.
Yes, thank you so much. Thank you. So, hi, everyone. Good evening. Myself, Ekta, and on behalf of the Brinalytics team and our partner, Expresso.ai, we welcome you all and thank you for being part of our webinar, Digital Transformation Using Machine Learning Series 2, Scaling with AI Implementations, Use Cases, Role of MLOps. So before we start with the webinar, I would quickly like to highlight few guidelines and make you people aware of. Requesting all the attendees to be on mute when the speakers are taking the session. There would be a Q&A after each session where the attendees can ask their respective questions, if any, to the speakers. You need to raise your hands, unmute yourself on your video, introduce yourself, your name, company designation, and put your question to the concerned speakers. So to start with first, I would like to introduce our partner, Expresso.ai. Expresso.ai enables to manage, build, and automate the entire AI ML application lifecycle from research to production with an integrated unified platform. With security, governance, and compliance as a core foundations of the platform, Expresso.ai relieves data scientists from the concerns of DevOps and deployment, leaving them to focus on doing what they do best, building models and algorithms. So from the Expresso.ai, we have experts, Mr. R. Krishna Kumar and Mr. Jaspal Singh Khalu. To speak about Mr. R. Krishna Kumar, he has over 25 years of experience with proven expertise in architecting large systems and designing enterprise-wide solutions for data management. To speak about Mr. Jaspal, he is a VP Market Development and has over 20 years of cross-functional experience with startups and mid-sized companies. At Expresso.ai, he is building user base for Expresso across industries and across geographies. A bit about why we all are here today. Artificial intelligence and machine learning no doubt remains the hottest topic in the discussion for the past few years. Implementing machine learning solutions to boost business profitability remains the first measurable goal of digital transformation strategy. And a lot has been talked about MLOps as a clone of DevOps for machine learning. So today we are here to gain expert insights from the industry leaders from South Africa, talking about the importance of LMOps. And now, to start with the first speaker, I would like to invite Nozifo Duma and to speak about her. Nozi is currently working for First National Bank FNB as data head within a business unit that looks after the decisioning platform capability, advanced analytics, and is helping First Rand move towards an innovative, contextual financial solutions platform. She is passionate about customer experience, business data driven, and technology initiatives. She possesses 12 plus years of versatile industry experiences. She has a strong experience having worked across multiple geographies like Asia, Africa, Europe, and Latin America, and has acquired many skills ranging from IT and business. And she is here with us today to share her insights on AI use cases in financial services, elaborating some five outlining the process, solutions, and the challenges faced. So Nozi, over to you to take your sessions. Chandra, can you please stop the screen sharing? Thank you.
Awesome. Thanks so much, Ekta. Really appreciate the opportunity. Can you guys hear me?
Yes, you're audible and clear, Nozi.
Okay, fabulous. So quite excited to talk through some of the financial use cases. So yeah, let me just share my presentation and we'll get cracking. Okay, so let me know if you can see my screen.
Yes, we can, Nozi.
Okay, fabulous. So I can't see myself, which is actually even better for me, but hopefully you guys can still see me on the side there. So I guess the session really, or my slot, is just to talk through some of our some AI use cases that we've implemented or I'm aware of in the financial services industry, and some of the challenges or work in progress that we're busy with. So I'm just going to take you through some examples, and then I guess if questions come, I'll take those at the end. Okay, so the first one here, very close to my heart, because I'm currently in an area, like Ekta was saying, that looks after dynamic decisioning and automated decisioning that happen off the back of a customer's product offering, right? So if you, I mean, most of us have bank accounts, most of us have bank products, and bank products, you know, are not always tailor-made for you. Sometimes they are, you know, quite generic. So using predictive and analytics that's very data driven is key, and that entails just us being able to utilize a lot of data sources, whether those are internal to our organization and or external to our organization, and really looking at, for example, Edgar as a person and looking at Nozi as a person. Both of us may be different ages, we may like different things, we may spend differently, we may save differently. So targeting you know, these offers and products offerings that we have available as a bank to you that meets your targets. This also looks at things like predicting when a customer is going to take up a particular product. So if you have an affinity for I don't know, so let's say maybe you want to travel, and you know, you want foreign, and we can trace based on the activity that you do in the past history, that you actually typically travel on this particular time, you go to these places, because we can see the swipes that you've had internationally. We can then use that data to almost predict that time when you're going to do that, and also offer you services that may talk to your travel experience. So things like, hey, you could potentially look at foreign currency, or giving you some foreign products that are related to your travel, and or even push non-financial transactions, like, you know, you could go buy a ticket on our app, and you can quickly go log onto the app, and it's integrated to various platforms that you can buy flights on. So it looks at things like that, monetary as well as non-monetary types of actions or product offerings as well. And most of these, of course, are done in real time, and they're specific to you. So it's, I mean, yeah, so it varies. I can talk through a lot of example, but heavily around just predicting the offers that you take up, what they look like across the spectrum. And then another use case really is this robotic process automation. We've actually got a tool. It's a life insurance tool, and this tool is quite powerful. And the guys that worked on it really did a great job. And you can read up about most of these things. They're available on the web. It's a tool that you push a lot of data into it, various variables, things like, you know, the customer's financial situation, what their life insurance looks like, do they have any disabilities, do they have any critical illness, and then the tool takes that information and it works out what life insurance product we can actually provide for you, basing all this other information. And the tool is made available to our agents in our call centers, and the call centers actually can view what these the recommendations are. And when they have the sales discussions with a customer, they can obviously also look to see if there's any offering for this customer and walk the customer through that journey. And it's quite nice because it also, we did find that a lot of people, especially in South Africa, require a lot of guidance around financial advice and also just life insurance. And it's empowering our agents to have those conversations, and obviously for us to tap into that market. So that's one example of a robotic process automation that we've implemented. Machine learning, artificial intelligence, yeah, we're making some headway here. In fact, our risk teams have implemented a solution, an AI solution called Manila. And this solution really looks at almost the risk and the fraudulent activities that can happen. You know, I mean, you look at people like MasterCard has millions and trillions of data, and they can tell you if you've swiped a certain swipe or a certain transaction that is fraudulent or not, because they've built almost these rules, and they've taken the historical and tons of data to make sense of it, to say, okay, when this happens here at this location for this type of transaction, or it happens repeatedly like this is what we think could be happening. So this tool is very similar to that. So it looks at, yeah, like components around financial risk, money laundering, fraud, inside trading, and it also takes a hell of a lot of data that's resides on our it resides on our big data platform, and it takes those data elements, large data sets, and it punches it into the solution, and the solution is then able to provide almost like a written analysis and rationale around indicating, okay, then so what is the behavioral evidence around this financial crime? What is it? And then what then happens is that the analyst, so now you can think of these are the data scientists or some of our data analysts or quantitative analysts, but the guys on the ground that service and help this function, they then use that written analysis to make sense of that and make a final decision on whether indeed this is a high risk financial crime or not, and then they can action upon that. So you can just imagine, you know, the power that this tool and or solution has provided us, because before a lot of the analysts would have to sit and do a lot of the wrangling of the data, getting it together, getting different versions, looking at it, quality assurance, etc. Whereas now a lot of that is done by Manila, this AI solution itself. And this is also really starting to equip our analysts to focus more on the quality controls, because we all know machines can make mistakes, right? And they need to be trained. And that's my last point there, is that also as this AI solution evolves, quite important for us to continue to train it and improve it. And by train it, we mean, you know, look at what it spits out, review it, vet it out, give different types of data scenarios, and go through that, and then apply the changes as and when need be as you go through that. Okay, so that's That's one example in machine learning and artificial intelligence. Image analysis. So, I mean, a lot of you will know, you walk into certain malls or you walk into, I mean, even when traveling, there's quite a lot of facial recognition systems or technologies that are out there. We able to actually get your selfie, and you can take a selfie literally on the app, and then taking that selfie, we take the facial recognition and we then go vet and confirm that with Home Affairs. So Home Affairs holds the records of citizens in our country, right? And check if this is actually the person that this person says they are. Because typically we would require your ID, it must be certified, we take the copy, save it, etc. So in some of these instances now, we don't have to do that because it's also FICA approved. So that's quite a nice tool that we've put in place. There's also, of course, systematic imaging that we've got, where we've got, voltage of IDs and home addresses, data, etc., where these tools are also able to start now figuring out whether this ID is correct, this type of document is an ID, this type of document is a statement, or this type of document is an address, etc. So there's that component as well. And then also, I mean, in some of our branches, we've got these mini ATMs that use biometrics. So you showcase your thumb, and then it verifies you, and you're able to do self-service on these mini ATMs. So things like withdrawing your cash, you can make transfers, you can open your account. So quite slick, and they set up quite nicely. So, if you walk into a branch, obviously you can be assisted and go and perform that. But if you just want to do what you want to do on your side, it's quite cool. And that's really what we all about as well, is improving on self-service, so that our customers can work on our apps and our online banking platforms, that they don't always have to go inside the branch. But of course, there's still quite a big need for branch networks. Okay, so those are some of the, I would say, use cases. Look, I didn't want to go into a lot of the examples because all of these categories themselves have plenty, but these are some of the notable ones that I thought I'd talk to. Then just in terms of challenges and some of the things that we need to look out for, especially in this AI ML world, is quality data. So by that, it's not just a game of volumes, it's also about the quality of the data, and then getting the data available to us in one single place, so our data platform, and utilizing that to improve all of this information. Because the more you know about a customer, the better decisions that you can make about them. The more that you have information to improve a particular tool and data set, the better the tool can perform. Likewise, even with the life insurance robot tool, it's in different versions now because we keep on improving it with different elements and sets of information that we're pumping in there and scenarios that we're pumping in there. So very, very critical that we focus on that and continue that journey. Then, of course, I think I alluded to it when I was talking about the Manila solution, the AI solution, is training these tools. So definitely there's still lots of work for us to continue to train these tools with correct data, to verify them, to test it, to carefully manage the tools over time. It's nothing like, I like the example of like spam mail, for example. If your email continuously says, for example, I don't know, an email from your mom is spam, it's going to irritate you. Then you have to tell it that this is not spam, and then you mark it as not spam, and then it goes into your own box going forward. So similarly with these tools and solutions that we build, the same almost rigor has to be applied, and so that we prevent these mistakes. And then the next one that I've written is just the upskilling and repurposing of roles. So we are seeing a lot of uptake or needing to just step change around, data modeling, proper data modeling, around physical data modeling, the ETL development, also the productionization of models and running those on the various languaging tools on platform. It's not, it's not a lot of people, at least always that have that skill and expertise. So there's quite a lot of that. And then obviously there are people who know like the processes of the business and our solution SMEs or subject matter experts in a certain field or topic or theme or grouping. And those guys are also like almost repurposing themselves into these more, I would say, technical um, um, data and analytics type roles. And they are putting their hands up to do that. And I think there's room for that to grow and also to just build up the next people in line, etc. And then importantly, the last one is just, we need to continue to look for more opportunities to use AI, ML in our business in various areas. And I think, where it makes sense, of course, it won't make sense in all use cases or scenarios, but there's definitely opportunity to continue to do so. So Ekta, I think that's, what was that? Was that 5-10 minutes? I think I've
Yeah,
covered
it's perfect.
what I wanted to cover.
Yeah, that was
Thanks.
perfect. Thank you so much, Nosy, for the interesting session. And quickly, we have a question from on the chat box, if you can see, from Nazma, that is RoboTool an open source or built by FNB internal?
Sure. So good question. Predominantly built by us, eh? Predominantly, a lot of what we do is in-house. We do get almost skill sets, consulting type advisory work that may be external, but a lot of our stuff we build.
Okay. And there's one more for you. That's from Martinus. He's like, I'd be interested to hear what models they are using for things like life insurance. First three sounded more normal mathematical. Modeling as a black box ML model, I would think it would come with a lot of legal trouble to prove your data outcome. Isn't it discriminatory? I think if you can read, this is usually told that actuaries instead implementing, not ML engineers. So what do you have to say? I think he shared an insight rather than asking a question.
Yeah, I mean, I think his insight is right. A lot of it has to do with a combination of that. So you've got strong AI and you've got weak AI, right? So it's borderline in between for some of these. So yeah, you definitely, you're nailing it there. It's a combination of both, but there is a lot of automation behind it, a lot of reasoning that the tool actually can do by itself. I mean, a lot of actuaries did contribute in building that as well. So yeah, fair.
One more for you. It's like AI with IoT is used in other industries than financial, like mining and manufacturing. So the question is, does financial services use IoT? And if yes, then how?
So my experience, sure. I haven't seen a lot of that usage, I must say, in the financial industry. And you rightfully say, I mean, things like healthcare, deliveries, etc. There's a lot of that. I haven't seen a lot of that usage in my work experience. But I'm not sure about, other areas or banks. I'd be interested to hear from you if you've seen it elsewhere.
Okay. Okay, last question. We'll quickly take that. It's okay. Now we are getting a lot of questions, Nosy. I think Nosy, you're going to stay back, right?
I'll be here.
Great. So I think we'll move to the next session, and we have a question from Michelle and one more person. So I'll take that. I hope it's okay with Sia Bonga and Michelle that we can take this question after the second session or third session.
Great. Also, I can also pop the answer there.
Yes, a lot of questions coming. So it's interesting.
Okay, cool.
Yes, it's interesting. So thank you, Nosy, for being here and sharing your insights. Please be there around because we have a lot of questions for you.
Okay, fabulous. Okay. Thanks, guys, for coming, and thanks for this opportunity. Bye.
Yeah, thank you. So now moving to our next session, I would like to invite Hartnell Ndugi, Chief Data Officer, Absa Bank Kenya PLC, To speak about him, his specialty is in the banking and financial services sector, where he has been able to master the development and execution of key data strategies for large bank and financial institutions. He's currently the Chief Data Officer, where he leads the artificial intelligence, data governance, business intelligence, and analytics team. With a deep understanding of data science, cloud computing, data management, business intelligence, advanced analytics, and governance. He seeks to ensure that organizations are able to set dynamic data teams, understand what data they hold, harness actionable insights, and deliver key use cases encompassing profitability, AI, operational efficiency, product development, and growth. And he's here with us to share his insights on how our MLOps platform speeding AI implementation. Over to you, Hartnell, and thank you for being here.
Thank you so much, Hector, and I'll just go ahead and share my screen. So just confirm for the rest of the colleagues if you can see my presentation.
Yes, we can, Hartnell.
Awesome. Yeah, so when I got this topic from Hector, actually, I thought it may be a very technical topic or concept to discuss, but I did my best to just come up with a deck of slides which just tries to explain how you can actually, one, understand MLOps. I am from the banking and financial services sector, so I'll just try and use examples or use cases that you can actually be able to follow through easily. And the second thing is just to understand how MLOps is actually being used currently in an enterprise fashion. And number two, how is it helping the people who are developing ML as well as AI models to actually be able to put or take your complete developed models into production. So quickly, I'll start off. I think the introduction was well done by Hector, but we can connect further at LinkedIn and just be able to discuss. My experience has been in data, cutting across different realms of data, from data management, governance, business intelligence, analytics, data science, AI, MLOps, AI ops now, also in model risk management, and a bit of consulting within the telco, industrial, and financial services markets. So let's connect on LinkedIn and discuss further. But I'll start off with a definition of MLOps. And basically, it is a mouthful, but MLOps is an engineering discipline that aims to unify ML system development, ML systems deployment in order to standardize and streamline the continuous delivery of high performance models into production. And basically, it looks at three key specialities or techniques, one being continuous integration, continuous delivery, and continuous training. So basically, for those who are not data scientists, within data science, you do have concepts whereby one, you have to collect the data you require for your model build. Number two, you have to see how you're going to train your data so that you can understand the use case or the study you're trying to solve or hypothesis you're trying to answer. Then after that, you have to fit the model and ensure that you are able to use it to predict or to answer the business problem that you're trying to solve. Now, for those who have taken courses on data science, most of the time you will see Python being mentioned. Those ones who have tried to install Python or R, Revolution R, they will give you a desktop application to start off with. So you either get Anaconda or you get Revolution R, you install on your desktop and you're able to create some of these models. And basically what you're doing is basically desktop data science, whereby you extract data, load it into your computer, you're able to pull the models and you're able to try out different things from fitting, testing accuracy, prediction, prescription, and you're able to say that you've built a model and you do understand data science. But what really matters is actually how you put your models into production. Remember, if you're talking about an enterprise platform where you're dealing not only with a small data set, but millions of records, for example, within the financial services sector, then you are talking at 2 million or more customers, and you have to be able to understand different patterns. So the data is actually immense, and the kind of models you build are supposed to be put into production. Putting into production here means that once you build your model in whatever tool you choose, then you have to find a way of moving that model from your desktop into an operationalization system so that people can use it in different departments and different branches. Now, the native way that has been done is basically a data science comes with his laptop or is tool and is able to build a data science model or AI model. What happens is that after building, you actually take the work to a data engineer. And an engineer, what he does is that he finds a way of creating pipelines for you. If your code is stored on R or it's stored on Python, then already some of the key players within the original equipment manufacturers, that's your Oracle, your IBM, already have plugins that ensure you're able to connect into R and Python, are able to put your data into an enterprise database or data warehouse for your consumption. Now, after that, again, the engineer has to keep on checking for new data and creating ETL programs or scheduling programs, whereby when new data comes in, you are seeing or looking for ways on how to ensure that the code is rerunning. Now, that's the old school way of doing it. And I'm just going to go to my next slide and just show you that within the area of machine learning, ML code actually forms the least part of everything else when you're talking about operationalization. So you can see ML code is just one small box at the center, very dark colored, reason being you do have to have the right kind of skills to be able to do that. But look at the other boxes surrounding ML and making sure that your machine learning code can be used in a production ready format. So configuration, collection, feature extraction or feature engineering, verification or validation, resource management, what kind of laptop or computer or server do you have, analytics tools, visualization tools, process management tools. So if you're actually just doing basic data science from your training laptop, then it's very easy. But you're talking about creating treasury or market kind of models that are going to be able to predict in real time or use, for example, Kafka streaming data in real time to give you usable models from the business perspective, then you have to consider all of this in one single fashion or format. So what are the challenges we do face when you're talking about moving from a data science kind of desktop application production environment to an enterprise machine learning operationalized environment? So my next slide is going to cover that. And I just list for you 8 challenges. There may be more on why we do require MLOps. So number 1 is time. So you can imagine the time taken for you to fit your model on your desktop, give it to the engineer. The engineer now goes and fetches the data, checks, you have to go to a development cycle. So with the new way of doing things, which is MLOps or model ops, then you're actually seeing that this time is actually reduced, and I'll explain later why. Second challenge that we're trying to solve is obviously complexity of putting your code into production. A research by Gartner showed that out of 100 models developed by data scientists, only 13 make it to enterprise production environments. And these are the guys who work in NASA, Google, Microsoft, who have already said understanding or understood or even invented some of the concepts within MLOps or model ops. The next one is obviously collaboration. When you're talking about machine learning, as I said, it's desktop development. If you're still using Revolution R or you're using Python or a standard installation. Next challenge is obviously operationalization is usually manual. So as I talked about manual handoffs, I have to put my code, place it in a software or pass it over to someone else. So you're trying to avoid all these manual processes that are involved in actually putting your ML models into production. Then native ML tools like Revolution R were actually not built initially for enterprise deployment. And you're seeing that new concepts are actually coming into place. And just a fun fact, as I keep on discussing, MLOps came from a combination of data engineering, data science, and DevOps. And I think for those who have been able to use DevOps in different development environments, then you're able to see the fluidity and the simplicity of putting your code into production and maintaining it in a regular fashion. Next challenge, reusability. I think it's still a challenge here. I'll move to the next one, hardware management. You have to think about your software and hardware as well. And the last one is subversioning of code, whereby you have to use complex model management systems. So let's double click and go deeper and look at how do you organize MLOps, or how do you organize the life cycle of machine learning to get yourself from a hypothesis to an actionable production model that is sitting in an enterprise infrastructure. So the first part is obviously machine learning, which I think 90% of the data scientists I hire, everyone knows about the basics of machine learning. One, acquisition of data, understanding cleansing of the data, understanding distribution checking, understanding variable selection, understanding model selection, validation, and all those different steps of machine learning. And you end up with a suitable model that has been checked, either an out of time kind of check or checking for accuracy and validity, that it works for you. The second part of enterprise machine learning is development. Now, the model you have developed only makes sense to the data scientist or the AI engineer who developed it by himself. You have to be able to have a way of putting this code into a production environment. That's where you have deployment ways of doing this. And here you have to create, plan, verify, and package a solution. R-Shiny was one of the methods I think R tried to do this, whereby they were letting you deploy your R code into a production-ready developed interface, but it didn't do such a good job. Now, these days I see people combining R, Python with Oracle, OBIE. I've seen people combining this with Tableau, ClickView, and different kinds of visualization tools. But the last one is actually operationalization, whereby you actually keep on adding new data, releasing your updated models into production, configuring them if there are any changes with regards to features, and keeping on monitoring how they're performing. So this is the life cycle and the different steps of enterprise MI, and a better visual look will look like this. Now, this is Gartner's view of how you're supposed to have an end-to-end understood machine learning development cycle. And it starts off here, whereby you're sourcing for data. And this can be either through your Kafka streams, can be either through structured or semi-structured data or distributed computing infrastructure. The second one is obviously integration. How do you pull your data into your environment where you're able to create models? And that's where your engineer comes in to help you. So you can see your cool engineer standing there. At this level is where data scientists come in with their cool taekwondo belts, and they're ready to slice and dice the data, have more of data engineering just to understand distributions, understanding features, do a bit of feature engineering, model selection, model engineering, and train your data. Then you end up with actually a usable model, but the model cannot be deployed into production without having a proper model management system, whereby you have a registry of what model and what were the accuracy features that came out of the model. What is the model trying to do? What are the changes that have been introduced by the last update of data? How does it manifest? What is the deployment frequency and time? And monitoring the health of the model. Is it dwindling with regards to the accuracy? And again, that's why your ML engineer, AI engineer, architect, or data engineer sometimes comes in at this level. Now, comparing the last part of delivery, that's where you have to have a user-friendly approach of delivering the value of solutions of the model to the users. A simple example within the banking space is that if I want to create a model that is able to predict the macroeconomic variables, maybe the price of oil or the USD KES or the currency pair trend for the next 6 months, then I can use multiple time series models, but I have to present the data to the user in a fashion that they can use it for different kind of decisioning. So that's where you're supposed to come up with an application developer or a system developer who develops for you a service or an application that can be consumable by the users. And each time data comes in, we have to keep on integrating it. We have to ensure that the data is fitting the model features that were selected by a data scientist. We have to ensure that the updates are put into the model registry by the model management system. And we have to ensure that the data is now well presented to the users at the end of the new iteration of new data. So you can see how complex it gets. And that's where MLOps comes in. And we have taken the last image and compressed it into a very simple architecture, which shows you, one, the use of data pipelines to be able to do all those things in a few series of steps. Now, as I mentioned, this technique was borrowed from DevOps engineers, data engineers, and data scientists. And we combine all those skills to have a clear view on how to deploy MLOps, or machine learning operations architectures. So what you're seeing down here are just some of the companies who have been able to help with the advancement, and they're doing this so well. There are so many white papers on how you can use Azure, AWS, Google Cloud to run different kinds of MLOps architectures. And what I'm showing you is just a generic one that can work for any of the three musketeers. So it involves simple things. Number one, we are now sitting on the cloud. And with the sitting on the cloud, you do understand the concepts of cloud native and cloud fast, whereby you actually are storing your data on the cloud. So it's easier to pick different services from each of any of the three service providers or cloud service providers to build your ML environment. for the end-to-end development and deployment of your model. So simply what it does is that you will go, and I don't know what each of you use for your cloud architectures. I can give an example with what, let me see, let me use AWS. So data pipeline for AWS, you can just use any kind of ETL service. So there is AWS Glue or Amazon Glue, which helps you ingest data and prepare your data and can also help you validate different kinds of parameters for yourself. Now, if you go to development or you're building, training, and creating candidate models, you can use AWS SageMaker, which will help you with creating and pulling different kinds of services that will help you train, validate, have confusion matrices for your different models. Into pre-production, you can still use your SageMaker, which is going to help you rank and validate your models using a series of steps before you go into deployment, where you can use different kinds of visualization services available on the cloud. Now, why MLOps gets its fame from is the ability to do the things listed down here. Number one, model management is now run using triggers. So basically, when I actually develop my end-to-end model infrastructure, what I'm supposed to do is just set up triggers for different kinds of events. Event number one, you can see the blue line coming to the model part. If new data comes in, I can say, for every new data element come in, please validate the data and retrain my model. And that's where the aspect of continuous integration and continuous training comes in. Now, after I've rebuilt my data using a model, I have a second trigger, which is a second blue line, which tells you select and validate the right candidate model after I've gotten my new data. That's where continuous delivery and comes in here, whereby as I get new data, my model is still being refitted, and I'm actually seeing in a dashboard somewhere the new accuracy specs of my models, the validation specs of the model, and new kind of confusion matrices, just to ensure that I'm still running the right kind of model. And the last trigger is obviously on deployment. If all methods and all ways or all considerations are checked off, then the next thing to do is actually ensure that I have the right kind of model in the deployment phase. So on the last slide, Hector, benefits. So I'll quickly just go through this. Number one is obviously speed. I've mentioned that you're no longer using desktop solutions. You're now faster. The second one is obviously consistency. When you have actually automated most of your ML development and operationalization, then things move quickly and faster. The third one is obviously iteration agility. As new data comes in automatically, things happen by themselves. You just have to check and monitor for the health of everything sitting in your MLOps architecture. Scalability and complexity. You can run very complex models if you actually deploy MLOps very well on cloud. And the last one is obviously interoperability, whereby you actually get different kinds of services working with MLOps. And that's me. Thank you so much.
Thank you so much, Hartnell, for sharing interesting insights and making a wonderful presentation. So when you were taking the session, we had 3 questions coming in. So, and we had Expresso.ai team, Mr. Jaspal and Mr. R. Krishna Kumar, who are lovely, taking good care of answering all the queries that you guys are having. So we had a question from Anton, I guess. So he had asked a question. I'll just tell you. Does cloud providers like Azure and AWS not take away many of the challenges with operationalizing ML by providing the services? So what is your thoughts?
So my answer here is this. Cloud providers actually do provide the services for you. But remember, MLOps is a concept. There are different ways of actually fitting the different services to work for you. So if you are in a banking setup, if you are in an insurance setup, I will actually recommend different kinds of architectures. So your answer is right. They do simplify most of the work, but the architecture work still goes back to you and how you want to build things.
Yeah. Thank you, Artan. Thank you. So any insights coming in from Mr. Jaspal or Mr. R. Krishna Kumar on this? I would like to invite any Expresso person to come and share their thoughts.
Yeah, hi, this is Krishna Kumar. So Hartnell, firstly, thank you very much. Let me just switch on my video. Thank you very much for that presentation. I think it was a very knowledgeable journey through the whole area of MLOps. It's a fairly new concept, and only in the last 2 or 3 years that it's really become very popular. So thank you. Excellent presentation.
Thank you so much.
Okay. So thank you again. So moving on to our next session, I would like to invite Tishipo Macwella, Head of Data Science and Analytics, Consumer and High Net Worth Client Risk from Standard Bank Group. He has 10 plus years of experience and is responsible for all the data science and analytics related use cases within the BBB credit area, managing a team of data scientists and analysts, and is going to share his insights on guide to CTOs on AI ML implementation. Over to you, Tishipo, to share your session.
Hi, let me just check if can you hear me?
Yes, Tishipo, you're loud and clear.
Yeah, I can't share. It seems like my camera is giving me issues. So I'll just present. And unfortunately, my camera is not working. So I'll get into it. Let me
No
see if I
problem. Perfect.
maybe, okay, I'm just checking how I can share my presentation. In the meantime, let me just introduce the guy that I'm with, that he will be assisting, through this journey. And we work closely with him. I'll give him some time as well to introduce himself. He's a senior manager at Standard Bank, within the credit space as well. We work closely with him. So I head up the team, and he's one of the senior managers in the team. Very insightful, quite good with this work. And I thought maybe it will be that he shares a thing or two. So I'm gonna, I will, how do I unmute? Abel, are you there? Can I just unmute? I'm just going through the list quickly. I can't seem to find him.
Abel, is it
Hello?
Abel? Abel is here? Yeah.
Can you hear me?
Yes,
Yes,
Abel.
Abel is here. Abel, do
Okay,
you wanna
cool.
introduce yourself quickly as
Okay, cool. Cool. Hi everyone. Yeah, no, I'm actually, my laptop is a bit far away from at the moment. I'm connecting through a monitor, so the camera is a bit far away. So I'm just gonna introduce myself. So my name is Abel Mnyageni. So I work closely with Tsepo on credit data science. So yeah, I mean, we look at different use cases from a credit perspective, but also we expand on that in terms of other things that we look at, such as fraud detection, and we do other analytics from a customer perspective to understand how the customers behave. So yeah, So as I've said, I work closely with Tsepo. Then Tsepo will be taking us through the ML or AI implementation, and I'll just add on throughout the presentation. Thank you very much.
No, thanks, Abel. So I'm just gonna give you a guideline on how at Standard Bank we implement these AI and machine learning models and systems as well. And as Abel said, we support quite a lot of teams. We're working closely with the fraud team. Abel has actually built a model for fraud, and I've actually worked on a lot of application fraud as well. We do a lot of credit-based modeling as well. So all your PD models, we support the scorecard team within Standard Bank. And for the past year, we've been on the journey to also, give assistance to our collections team. So we've been working closely with our collection team, and hopefully, we've got some guidelines, but we can tell you some of the issues that are faced, and how we as credit data science, we go about implementing any of the machine learning and AI life cycle. So I'll let me just highlight without. So there's an overview. We'll take you through some of the use case and we'll point out. But a lot of these things, I mean, we'll just speak into those things. So it's important that you note them down. And as we present, if there are any questions, we can take them maybe at the end. So this is an overview, essentially from us meeting the stakeholder until, deployment, monitoring, and maintenance of such models that we build within Standard Bank, but also assisting, as I said, the fraud team, credit collection. We have some work that we're doing with card as well. So we're quite involved in a lot of models that they build within Standard Bank as a whole. We're not only helping South Africa, but we're also helping the rest of Africa. As you know, Standard Bank has offices elsewhere in Africa, and we assist in those teams, building data products. And making sure that not only are we building, but ones that are stable, over time, they can use them. And yeah, maybe let's go to Abel, you can jump in each point. So I think the first point, and in any data science, implementation, we've noted some of the most important aspects. And I think understanding and defining the use case, we just pointed out certain things, engagement that you have with the stakeholder. And those engagements are very, very important. And, there's nothing that you can build in data science if you don't engage properly with the stakeholders. And that's understanding the problem that you're trying to solve, understanding some of the requirements that comes with the business. So for instance, if we're building a fraud model, typically how it would meet with the stakeholders within fraud, and they would say, this is what we want to build. We actually build 3 models there. And we'll give example of certain models that we've built for fraud and some of the business requirements that were set up. Now, properly defining the target or the response of your model or whatever AI model that you're trying to implement, that's going to be important, and it shouldn't be taken for granted. I mean, a lot of work that we're doing, depends highly on how the client would have defined what they want us to essentially predict, So that's very, very important. Choosing a matrix upfront. So we, these, and maybe the last one on deployment, these are stuff that should be done upfront. When we meet with stakeholders, we also want to understand, which matrix tends to drive the problem that we're trying to solve. So for instance, if you're building a fraud model, we tend to use F1 scores because they tend, so it's a combination, a weighted average between precision and recall, because they tend to drive how they would want to view their model. But if you're building collection models, in some cases, if for instance, you look at some of the scorecard models that we've been building, they tend to use the Gini score. So those things need to be explained upfront so that we're quite aware on which metrics we need to optimize. And that's very, very important. And lastly, deployment, and I thought maybe it's important for us to explain why deployment is very vital at a stage where you're trying to understand the use case. And that has to do with, where are we going to productionalize? Do they want it to sit on the cloud? Is it an on-prem kind of productionalizing? And those questions are very important. And we tend to ask the stakeholders those questions, because we're saying, guide us so that we know if a certain model is even compatible. We have issues around, as you know, the birth of machine learning and AI has got a lot of problems within institutions like banking. And one problem being, if there's legacy issues in any institution, not only around Africa, I think it's a world problem, where, they've been using models like your linear models, logistic, and they've worked over time. But now with the birth of machine learning, we need to check if the systems that are available at Standard Bank, are they compatible with, and there's also issues around regulation. You know, certain models that we build are quite regulated. So we can't really say we want to deploy this model in this type of system, or this is the model that we want to deploy. The stakeholder will have to, you know, mention those upfront. Abel, do you want to jump in quickly there?
Sepo? Yeah, I think you mentioned that you mentioned a good point around around system capabilities. Because yeah, I mean, in pretty much in every organization, you would have you use different systems for different use cases, right? And you need to upfront identify if there's any limitations. I
Yeah.
think Sepo, you mentioned a point around some systems would be legacy systems. So the use case that you'll be working on uses a legacy system where there will have to be quite a lot of integration that has to be involved in terms of where the model is going to sit and how you can actually go about deploying it. And at that point, that's where you have to then reconsider to say, in terms of the level of complexity, which models are you going to go with, right? So obviously, if there's a system dependencies and you can't implement a model that is way too complicated, then you need to then consider to say, okay, which models are going to be easy to be able to implement, considering the limitation of the system that is being used for the use case that you're looking at.
Yeah. So that's very, very important what you're mentioning, Abel. Actually, now that I'm thinking about it, we had a fraud model that has to sit directly on one system where our scorecards are sitting and everything is sitting, and there seem to be issues around, you know, implementation. So that has everything to do with the type of model you build, you know, and the complexities that surrounds that model. So there's a lot of issues when you build model. It's not and this, hence why these things needs to be set up upfront. You know, the data science team, the analytics team, they need to know about these things upfront so that they can, you know, create space for these type of implementation on a later stage. So without wasting any time, I'll go to the second point, and that's data sourcing and quality assurance. So we looked at a lot of data, you know, collection, and the reason why data collection is very important in our space is that not only do we deal with a lot of unstructured data, structured data, but we, you know, depending on the use case, we might have to consider unstructured data. For instance, when you're building a lot of collection models, and we don't simply do, but we do build a lot of collection models, there's a lot of voice data, you know, so us having to move the voice into, you can only work with voice at a text level, you know, so you need to convert that voice into text. And once you've got the text, that's when you can run, you know, any text analytics within that data set. So it's very vital at that stage to know what data can we collect, and and do we have systems as well to not only inject that data, but to, you know, convert the data. You know, that conversion is very, very important. For instance, you know, the whole idea comes back to the governance. You know, do they even allow voice data to go into cloud? You know, and in Africa, cloud is quite new. And I mean, you know, we've been jelling around how to use cloud, and, you know, and I mean, cloud is the only thing that can give you high accuracies in terms of those types of conversion. So that's very important. Web scraping is another issue, something that's very vital in the work that we do. You know, we had an industry use case where, you know, during COVID, a lot of people were losing jobs and all, and we had to analyze that. And, you know, it's the employment data is not always populated in any institution. And we had to go and scrape a lot of information to just assist that process. Data quality. Now, in any type of implementation, we need to check variable stability. Is the data that we're collecting, is it stable over time? We need to check the availability of that data. We can even, we don't want to sell to the stakeholders that we will find data that's going to be difficult for us to retrieve. So that is questions that we need to, ask upfront. And the whole issues around missingness in data, there's a lot of data that's not so populated, especially a lot of your demographics. So you look at age, you look at marital status, you look at race for one. Race is not populated, and it plays a major role when we do a lot of our responsible AI work. But that, because now the customer is normally given options whether they want to complete race or not, then it becomes an issue. We miss a lot of information on race and, a lot of demographics now in South Africa. Customers are given an option to complete them. And then we've got data privacy and governance. So the whole issue of governance is very, very important. And one thing that comes into mind is when we were trying to build our credit-based model. So these are your scorecard and so on. There's an issue around moving the data to the cloud, and Abel will touch on that. We've had a lot of engagement. Just moving the data into cloud seems to be an issue. And the issue of, what's the privacy there? Are we sure that the data is not going to be used in some format also? Because as you would know, there's a lot of privacy in that type of data. So we've went around anonymizing the data, which has helped at times, but yeah, there's still issues. So these are all the things around data sourcing and quality assurance, and needs to be said upfront with whoever that we're building the solution for. Abel, do you want to jump in there?
Yes, so thanks, Tepo. So just to add, one thing is around data privacy, right? I mean, I think Tepo, we have talked about we need to identify which data that we can have and we can model on, right? But another component is around which data we cannot use for modeling, right? I mean, we have things like transactional data, things like location, and all these different things, where the customer lives, where they're employed, and all these different things. It's about to say, okay, upfront, we need to say, okay, this is the type of information we won't be using for the model, for the use case that we'll be looking at. Because yeah, I mean, that would go under, like, pretty much under privacy, right? So upfront, we need to say, okay, this is the type of information that we won't consider in the modeling. So yeah.
Yeah, so that's on data sourcing and quality assurance. There's data exploration and engineering. I'm not gonna waste a lot of time there. So the injection and migration of data. That's one of the issues that we're facing in the bank. As I said, because of legacy issues, a lot of our data would sit on SaaS, where we 10 years back, that's where we were building all these linear models. Now came with the birth of machine learning and AI, we had to migrate most of our data. We're still in the process, and as you would have known, that's an ongoing process. We're still working hard in making sure that we can migrate and inject the data, and on the prem, we're currently moving most of our data into some lake that sits on Hadoop. And the guys, most of our data scientists work there. So it's only befitting that we move most of our information. That's an ongoing process. And in any institution that are currently using these machine learning and AI platforms, you would know that we're moving data into the cloud. And I mean, we've got different products, as you know, at Standard Bank. So, and it's also product driven. VEF might say we want our information to sit on the cloud, and because of privacy issues, one might say, for instance, home loans might say we want our information to sit on, still sit on SaaS. You can do callings from there. So there's a whole lot of issues around how we inject data and how we also migrate it to different platforms. Now, the data insight and storytelling. I always say if you don't do proper EDAs in any problem, you're going to face problems. You know, these EDAs, they give you initial insights, but valuable insights. You know, I think they are the most overlooked stage of your implementation. And if not done properly, you will lose a lot of, you know, I would rate that step of data exploration and engineering as one that drives the solution, one that's probably going to give you a high accuracy on your model if done properly. You know, so all those distributions that you do at that stage, just understanding your target distribution and so on and so forth. And now with COVID, that dimension has changed completely. You know, just understanding your target distribution. Now you've got, with a lot of models that we build, we've seen now a downward shift in a lot of our target rates because of COVID and so on. So because of that, I think that stage is crucial. Feature engineering or data engineering, fairly important as well. You know, deriving new features or deriving new information from the one that's existing within our disposal. That's very, very important as well. We've enabled, Able has done a lot of work in trended views, just having moving averages, gradient acceleration of certain variables. We've seen a lot of lift in a lot of models that we build within the team. Deriving life stages. So you could, take out some information or extract some information from social media, tweets or Facebook messages about someone's life stage where, and you can also derive that from transactional information. For instance, we've done a lot of expense categorization where we've said, someone who spends a lot of their money on entertainment, on gambling, maybe they're at an unsettled, time in their life. And that's quite valuable on what drives these type of implementation and models, essentially. Abel, do you want to add?
Thanks, Apo. Yeah, I mean, the information that we have at our disposal is pretty much raw information, right? And it's a matter of to say for the use case, how do you make sense of it? How do you derive new information out of already what we have? Which is important. I mean, like most of the models that we've built, we found that actually the information or the features that we create or that we engineer actually ended up being more powerful than what we had initially in terms of the raw data. And yeah, I mean, as part of the team, Tibo mentioned about the trended views, where we pretty much look at like how the customer changes their behavior in terms of from a spend perspective, right? Say are they spending way too much on non-essentials, or are they spending way too less on essential items and those kind of things. So yeah, it's very important from a modeling perspective, and also in terms of to help us in terms of obviously down the line in terms of the implementation. Thank you.
Yeah, so I'll go into model development. So a lot of implementation of these AI and ML solution, they start at model development, and that's not true. As I pointed out, those 3 or 5 points that we've just mentioned, they're quite crucial in implementing a good model, one that would be stable over time. And during our model development, we then come to a point where we're saying, in order for you to implement a stable model, but one that will actually be used by the stakeholder, because there's a lot of models that are built in a lot of institutions that are not used. So firstly, can we discuss the type of algorithm and the type of programming platform they want this model to be built or trained? So what we've noticed is that, we use a no free lunch kind of, attitude in the team, where not only do we build 1 or 2 models, but we build quite several models. They could go up to 5 models, and they would be built in a platform would have agreed with and in most of our cases is PySpark, which is a Spark which sits on our Hadoop platforms. And it might happen that with a certain model, a certain solution is built on one platform. For instance, when we're building our collection models, the voice solution, or we use the voice services that comes with AWS. So it's a cloud-based solution. So once we move from there, we then go into Hadoop. That's where we build our final model, using obviously the features that would have derived from the voice information. So that's very, very important. Making sure that you can harmonize the two, the cloud and on-prem platforms that we currently have within the institution. Now, the issue of speed, accuracy, and complexity trade-off, and that's no free lunch. So we normally build about 5 models because we think one model is not enough to understand the complexities within a problem. And what we're saying is that we need to make sure that we can run whatever process, the process is accurate, the process is less complex. If we can, if we've got 5 models, and typically what would happen is that they would go with the level of complexity. So you would start with a simple linear model. We cannot, because the client at times they would say, we want a linear model, so a logistic, they would say, we want a logistic, and that's it. We can see that you've built these nice models, but also if the trade-off is not a lot. So if I build a neural net and there's a 5% accuracy in trade-off or in whatever performance measure that we're using, then the stakeholder might say, no, we can still keep the simplest model. And that is just in nature, not only in the nature of the complexity, but how transparent the model is. So there's quite a lot of things that we look into when we build models. So we just don't decide that we're going to go with a light GBM because it performs well, but we check the trade-off. Obviously, machine learning model would, they would be much faster than your traditional models. They would be more complex, however, and they tend to be more accurate. But again, we need to check the trade-off. There's a lot of selection of variable that takes place within the team. We make sure that only the best and the most optimal variable will go into a model. We don't just allow all the models to go into a model. There is a lot of tuning that happens in a lot of these models, and then there's a component on explainability and fairness. So this is the responsible AI component that we currently implementing within the team. So as you know, a lot of these machine learning models, traditionally, they were said to be models that you cannot explain. But that has changed, in recent years when a lot of data scientists have come up. I know Microsoft is doing a lot of work on responsible AI. So are we saying can our models be explainable? And are those models fair as well? And an example with this fairness would be scorecard models. Those models are used to grant someone a loan, and we don't want those models to be biased over race. And you find that one race is getting loans much easier than the other race. So that component had to be added. And the explainability, are your model transparent enough for us to understand the effect of, at a global scale, what's the effect of these variables towards your target variable? But also at a local scale, can we, explain the decisioning? How does a model come up with a certain decision on a certain client? If demographics variables are influential, we need to understand that upfront. So those two components is a very, very important aspect that we've added at Standard Bank. Choosing the right performance matrices, as I said, I think we'd have discussed that during our would have discussed that part on, making sure that the right matrix is used. As I said, when you're building fraud models, they care more about, the precision and the recall. And if you build a scorecard model, they more, on the gene, which is a trade-off between, your false positive and your true positive rate. So all these things, they need to be said upfront so that we know. Impact analysis, that's where we put cost into whatever work that we're doing. At the end of the day, there's revenue that needs to be made by the bank, and we need to, that's where the impact, what we're saying is that if we're saying we'll build a detection model for fraud, this is how much we can save from building such a detection model. And hence that talks to false positive. Can we bring down the false positive, hence bringing up, or bringing down the cost, that's incurred during that. Model documentation, documenting your process. That's also fairly important, and we do that just for accountability as well. When we deal with stakeholders, we can say, but this has been documented. So that's one component of AI implementation that should be done. Abel, are you still there? I'm trying to run and I'm looking at the time. So
Yeah, it's about thanks. Tabo. I think you've covered everything. Nothing to add on my side. Thanks.
okay, so deployment, and we've started deploying, as you know, a lot of these machine learning model, they are quite hard to deploy. They're not traditionally your logistic or your linear models. So we've had discussion with different teams, and I'll start with the last point: the relationship that data engineers, data scientists, and the business at large has. That's very, very important. I always say a data engineer cannot do his work properly if a data scientist does not assist in explaining certain concepts and certain methodologies and platforms that we are using. And the business as well needs to be aware of what the guys are also doing. So that relationship is very, very important. And what I've seen over time is that in any analytics team, you don't only have analysts and data scientists, but you also have data engineers. They tend to come at this stage of your implementation, and that's making sure that the model is deployed, and also making sure that there is monitoring and maintenance of those solutions. Now, a few things I'm going to touch on here: the batch versus real-time deployment. Now, I know we've had a lot of discussions around how do we deploy our model? Do we deploy them? I mean, this is normally said upfront that this type of model will be deployed real time, and when applications. So for instance, a lot of our application models, like your fraud happens at application, so it will be a real time or a near real time model. So we need to make sure that those models, and we need to find platforms that are compatible with such deployment. On-prem and cloud deployment. I think the last speaker just explained everything about cloud and how it works. And all I can say is that it's not as easy as a lot of people think. We still need to engage with stakeholders to say, do you want your model to sit on the cloud? And that's moving the data into the cloud. Or do you still want the model to sit on-prem? Now, there are disadvantages and advantages of doing either. For instance, if you're moving to the cloud, the advantages is you've got a lot of services that comes with AWS or Azure, and you can use those services. Like, for instance, it will be quite impractical to do voice recognition or image recognition, for that matter, on premise. We don't have those capabilities. And if you're doing it on cloud, then it becomes easy because AWS or Azure or Google Cloud will come with those services. And but there's an issue of data governance. Can we move data quite fast? And what we've noticed is that the acceleration of moving data into the cloud, it's not always easy. I mean, Abel will explain, we tend to take, months just moving data into the cloud so that we can score on the cloud. So that has to be said upfront with whoever stakeholder that we're engaging with. And productionalizing the model. I mean, as I said, typically the way these models were productionalized, they were done on SES, and SES has a lot of capabilities at your disposal that would make your process to run a bit easier. But with these machine learning models, there's a lot of steps that needs to be involved in making sure that you productionalize your model on the on-prem. Abel, do you want to add on this point?
No, Chapo, thanks. I think you've covered it. Yeah, I mean, there's around the batch and near real time, right?
Yeah.
That as well, and like it also depends in terms of like where you're gonna deploy, right? I mean, I think cloud can provide you with the capabilities in terms of near real time, but obviously with on-prem, it's a matter of like how do you figure out how you're gonna do things like streaming and all those different things. But it also boils down to system integration, right? Say whichever system where the decision needs to be actioned on, in terms of how do you then integrate that to where the model is actually sitting, plays a part in terms of from a deployment perspective.
Yeah.
Thanks.
And that's important, Abel. I think one point that I should have raised is the whole idea around data, migration from different platforms. When you building your model, it's a bit easy for you to get all the data that you need onto one platform and build. But with implementation, there's a whole lot of complexities. When can the data land? That's another issue. We deal with we have a lot of bureau views, they don't land on the first day of the month. And a lot of these models, some of these models are daily models. So that has to be something that is communicated upfront with the stakeholder to say, look, we might have issues deploying this, real time, because we might not get if they insist that we want the model to be deployed real time and it's a daily model, then we might have to do a lot of lagging of information. So there's quite a lot that goes into deployment. I'll go into the last one, and that's monitoring and maintenance. So we do a lot of, we just track, the first one says automated and periodic reviews of medal performance. So what we're doing is that we check things like your accuracy over time, we check your gene, we check your false positive, because if one starts to drop severely over time, then we know there's probably issues. And that says, go back to step number 3, maybe retrain or do something. But also you need to understand the underlying, and hence why the data exploration, even at that step, is very important to say, what's the underlying cause of a decline, a sharp decline in accuracy? And this is something that we've seen during COVID. Most of our models, they declined in accuracy, but then we knew, looking back into doing some data exploration, we knew which variables were causing that. And that maybe, would result in us retraining the model without using those variables. That's something that needs to be discussed upfront with the stakeholder. The benefits of tracking, as I mentioned now, you need to track things over time. You need to make sure that they are stable, they are consistent. If they are not, then, we need to go back and do, proper planning. And hence, going to the last point on planning for future iterations, that's also important. What are we saying? Are we saying, I know we've built a model, like for instance, there's a best time to call model. That's a collection-based model. We've decided that we're going to update that model every quarter, for instance. It's not a monthly kind of, where we update the model, because a lot would have changed. And now with COVID as well, a lot of dimensions, have changed within the institution. So a lot of, institutions that we're dealing with might say we have to retrain the model, or we have to redevelop the model because of, the changes that we've seen in the data. So there's, in a nutshell, this explains how one would typically implement a model or a machine learning or an AI system. And that doesn't have to do with modeling only. It could be an unstructured problem where you're dealing with voice only, but in a nutshell, this is how you typically go about doing it. And this is how we're doing it currently at Standard Bank. Yeah. Are there any questions?
Yes. Thank you so much, Tishpo, for, wonderfully sharing your insights in great detail, talking about ML and AI implementation. So yes, before we wind up, we can quickly take any questions, because while you were taking the session, there were a lot of interesting chats happening. Yeah. So yes, any questions? Anybody would like to, Mr. Jaspal, Mr. Ramkrishna Kumar, anybody? Please share your thoughts or any questions.
I think Anton had a very good question on, he wanted to understand whether, can you use an agile to deploy an AI ML model, or it is best to use a traditional waterfall approach? So I think, with the experience that Shepu has and Abel have, shared, I think it is good that, they can comment on this as well.
So can I just get the question again? Can we use
agile to deploy an AI or ML model? And is it best to use a traditional or a waterfall approach?
Okay, Abel, do you want to take that first? Is Abel still around?
No, I think we have, Abel is not here.
Okay, so I mean, to be honest, these type of questions, they become complicated. I'll tell you why, because of what we just said. Firstly, it's stakeholder dependent. As much as we want to deploy these models in different types of platform, it's still, stakeholder development, and it's also use case driven. And what I mean with use case driven is that different use cases have different ways of not only implementation, but going into deployment, going into different types of platforms. So traditionally, as I said, at Standard Bank, they still use that, and the reason being, there's a lot of models that are still regulated, and the regulators would say, no, we don't want our model to be built in this way or in this type of platform. Hence, as a result, we might have to, rethink. And sometimes, as I said, we go into what we've done over time. We said, how can we maximize, still giving you a simple model at the end, but, how can we maximize the other stages of model, development? And that's what we've been doing, trying to maximize, as Abel would have said, how we engineer features, how we engineer the data. That has obviously added a lot of impact in the work that we're doing. But yeah, it's still driven in a lot of, whether it's regulated, whether they are regulated, because regulators are not yet there with this whole machine learning. And if you want to build, and there are stakeholders that are still not there. They still say, I would prefer a more, traditional approach. So what we're saying is that you can still use your AI and machine learning kind of implementation, but just give them a traditional model at the end. And as I say, if you look into this model, is just you building or training that type of model. It's just one step. You can still drive, a lot of, for instance, you can have a variable selection that is machine learning driven, and then still have a model that's, that's easy on the eye, that's simple to the stakeholder. So it's quite dependent on a lot of things. But one, as I said, it's dependent on the stakeholder. It's dependent on a lot of factors. Yeah.
I agree with you, Shepo, on this because simplicity is also very important. You have talked about that as well. So thank you so much. I think your presentation speaks about the the experience. It is just not like that. Knowing something and playing with the tool and it is all gone. It is a lot of iterations are there. There are so many other decision-making factors that are to be considered. So I think there has been a lot of exchange of queries while you were busy with your presentation. We had some queries. So the chat script can be shared by Ekta with you, so that in case you have a better feedback or maybe you want to add on to the queries that we were trying to answer, and we can circulate to all the attendees via Ekta. So thank you from our side, and Ekta, over to you.
Yes. So thank you, Tishupo, for making such an interesting session, as I told earlier. Thank you, Mr. Jaspal and R. Krishna Kumar, for being here and sharing, making the chat session very engaging by answering all the questions that we had. So before I close, I would like to update you all that we are shortly coming up with Series 3 by Expresso, which is a masterclass on MLOps with a live demo from Expresso.ai. So we'll have much more interesting session on MLOps and great insights coming from various other thought leaders as well. So please, my team will reach out to you with the dates, and we'd love to have you joining in for that session again. So on this note, I would like to thank our partner Expresso.ai, all of our thought leaders, Nosy, Hartnell, Tishupo, for taking out your precious time, being here with us and sharing your thoughts and lovely presentations with the audiences. We had lovely questions, and Jaspal and R. Krishna Kumar made it really interactive. So, and lovely audience, thank you for taking out your precious time being with us here. We have also shared the feedback form link. So I would really request you to please share your feedback, which also mentions about one-on-one brainstorm session with Expresso.ai. So in case you need to have a live demo or you need to know more about MLOps deployment, so please let us know. We'll be happy to connect you with Expresso team. And we'll be also sharing with you the video link of the YouTube once it is updated. And please follow us on LinkedIn, Instagram, Facebook, and Twitter for various webinars and updates. So thank you everyone once again for your time, and glad having you all here. And please take care and stay safe.
Thank you.
Thank you. Thank you, everyone. Take care.
Bye.
Thank you.